Swayam Prabha. Digital India. Educated India.
To this soil mechanics, and today I'll again start a new topic, that is earth pressure. So far we have completed origin, classification, index properties, permeability, seepage, then vertical stress distribution, shear strength, then compressibility, and now I am going to start on earth pressure. This is a new topic that for developing different type of facility like road, railways or similar facilities. Sometime we have to retain the soil. You may have to cut sometime, you may have to excavate, you may have to fill, and while doing that soil may not be able to stand by itself. So, you have to provide support by wall, and they are called earth retaining wall. And this earth retaining wall, when you do, then when the backfill soil will be there, based on this backfill soil, the pressure will be exerted on the wall, and how much pressure the wall can take, then we have to, for that reason you have to learn how to find out the pressure behind the wall and how it distributed, what are the major factors depend on which the pressure will come on the wall, where it acts, all those things actually you need to know. So, for that there are various earth pressure theories developed over the time. We will discuss one by one. Before going to that, we will see the different types of retaining wall, how principally. So, this is the different types of wall, actually retaining wall, and this retaining wall, first of all you need to know different retaining wall, the types of earth retaining wall. Okay. So, this is the major classification can be done. Externally stabilized system, that means what? Soil is not a fundamental part of the system. So, if I have a retaining wall, soil only give pressure, but in fact it cause instability, but it does not help anyway for stability of the system. So, because of that, externally stabilized the soil is not a fundamental part of the system, it will only give pressure, nothing else. And under that we have different types of retaining wall: gravity wall, typically small true gravity retaining wall, creep wall, gabion wall, cantilever wall. So, I will show one by one. Gravity wall means its stability depends on its weight only. So, it will be huge mass will be. So, typically gravity retaining wall will be something like this. So, it is huge and then retained soil will be maybe here. So, this is typically gravity retaining wall, and there is a creep wall. Creep basically you can say suppose we have a number of then so you can see so that means there is a this little incline, and you can see there is a member here. On this there is another member inclined in this direction, then there is a two cross member, then there is a member in this direction, then there will be two cross member, then member, like that one after another will make a system, and then soil will be retained here. Suppose it is a ground, okay. So, this is ground. So, this way when soil retained here, this type of wall is sufficiently flexible actually. So, during earthquake and all, generally it will be advantageous, since it will not collapse so easily, because it can tolerate significant amount of deformation. So, they are actually quite flexible, and these are all inside gap also will be filled up with soil. So, there are suppose this is planks, this is a cross plank, this is horizontal plank, and in between there will be openings, and those openings can be filled up with water and then soil, and then the backfill also soil. And so, because of this soil, it will give some pressure here, and some analysis can be done this type of wall. So, this is called creep wall, and this is gravity. And similarly, we have gabion. Gabion actually by using the either wire mesh or some other rope, strong nylon rope can be made, using those a box like thing can be made, and inside the big size of boulder will be filled. So, like that a number of them can be made, and we can do like this, one after one we can put it. So, like that, and finally, so this is not the diagram correctly. So, I can put like this. These are all gabion these are all gabion. So, it is here, then it will be step behind, so that stability will be better. Like the number of gabion will be there on the ground, and this will be retained soil will be retained. This is also, and each gabion will be interconnected, so that they are quite heavy. So, it is not so easily will washed away or fall. So, they are connected each other, and each one also shell point is quite heavy. So, all together will work like a wall, and this soil will be supported by this. This is also quite flexible, and hilly areas, this is a very good solution for retaining the rock and soil. So, this is one called gabion wall, and there is another type, that is cantilever retaining wall, that is generally made of concrete, and it will be typically it will be something like this. There will be, so wall will be like this, side soil will be retained. So, the cantilever means this portion is cantilever. So, this portion is cantilever. So, pressure will be there. So, because of that you have to put enough reinforcement, otherwise the concrete thin section will be fail. So, this is actually almost like a structural part, and this side soil will be retained, and this based on soil you have to calculate the pressure, and based on this pressure you have to provide the reinforcement here. So, this is typically known as cantilever retaining wall. So, they are actually all externally stabilized wall. Okay. So, the stability of the wall, it depends on actually this soil around and its weight altogether. And there are sometimes few in situ wall is there, that is cantilever braced. So, in situ wall means there is a some waterfront structure. So, we need to support the suppose jetty. So, suppose there is a, this will be penetrated, water soil is here, water is here, and soil is here. So, this type of sheet like metal structure can be penetrated, and this will be this side will be soil will be there, and on this there can be some facility. So, this is cantilever, this is called cantilever sheet pile wall, because soil is here, and beyond this is free, it will bend like this. Okay. So, this is a cantilever retaining wall. Then there is a breast. So, sometimes it is too high and deformation is too large, then this type of system will not work. So, in that case we have to tie it, and we have to connect somewhere here inside, so that the deformation of this will be reduced. So, this is actually typically cantilever or breast sheet pile wall. So, the externally stabilized wall, cantilever, gravity, creep, gabion, and sheet pile wall, all those things are externally stabilized. Now, Next, I will see the other one, that is internally stabilized system. Internally stabilized system means what exactly? Internally stabilized system means actually see that the soil itself will be act as a part of the stabilizing system. Soil is a fundamental part of the system. Example, reinforced earth soil nailing. So, reinforced earth soil nailing, what it is? All of you might have seen that nowadays during the close to the bridge approach and all, we will see some decorated facing element, and so typically it will be, if the wall is like this, unlike a gravity or cantilever retaining wall, it will be thin comparatively, and there will be small pieces, and each pieces with there will be some reinforcement connected like this, and soil will be filled up. So, when the soil will be there here and height is quite significant, then because of this will try to move, and then when it will try to move this direction, then this friction will develop between this reinforcement and the soil, and that way actually you have to design, of course, how frequently, how closely you have to put. If you design properly, then with nominal thickness of the wall and with this reinforcement in the inside the soil, one can make the wall, and they are actually quite popular now, and this is of course quite economic also. So, this is actually, since the soil itself taking a fundamental part, the soil and reinforcement, the interaction between these, whatever frictional force develop, that actually helping the stabilizing the wall. So, because of that, this is called internally stabilized wall. So, this soil and reinforcement, they together interact and make the system stabilized. So, reinforced earth is the example, and then there can be soil nailing also. Sometimes there is a hill area, and sometimes we cannot make a very flat slope. Okay. So, in that case, suppose you desire to cut a slope like this, and then this slope may not be able to stand itself. So, in that case, to strengthen this, we generally provide soil nailing. So, at sufficient depth inside at some inclination, soil in reinforcement rod will be first make the hole, and then grout and rod together will put together, and then finally it will be sealed here. So, all together will make a system like a wall. So, that is called also soil nailing. So, this is also a internally stabilized system. So, this for all those things, of course, while designing, whether it is a gravity retaining wall, whether it is a creep wall, whether it is a gabion retaining wall, whether it is a cantilever retaining wall, or whether it is a sheet pile wall, or whether it is a reinforced retaining wall, everywhere we need to actually calculate the pressure over the depth. What is the pressure behind the wall? So, that pressure actually is essential for calculation, that what will be the depth, what will be the thickness, what is the reinforcement, all details can be obtained based on that amount of pressure we get from the wall. So, that can be for that actually we need to learn the earth pressure theory. So, we will discuss that now, different earth pressure theory. You can see earth pressure. Why study earth pressure? Okay. So, this is basically design of foundation wall, basement, safe excavation during construction, and design of earth retaining wall. All for those cases actually we need to know earth pressure. So, design of foundation wall, that means basement. Suppose you have your building starts from here, but you have some system below. Okay. So, basement. So, in that case you need to find out the pressure on this wall. So, that is one. Safe excavation during construction, that means how much depth you can, suppose you have to do for construction purpose, you have to make some excavation, and that excavation whether we can do without support or we need support, how to find out? Actually, you have to find out pressure, and based on that you can. So, suppose metro rail cut and cover method, they will quite deep you have to cut. Okay, you have to go metro rail maybe somewhere here, surface is somewhere here. Such a high wall cannot be just like that. So, what you have to do, we have to give in between support. So, so there is some design. So, how to what will be the support, what is cross section, what is the spacing. To find out that, you need to know the earth pressure. So, these are all various areas requirement of earth pressure theories. And earth pressure now, what are the different types of earth pressure? There is a earth pressure at rest. At rest, earth pressure at rest means what? There is a wall, suppose, and retaining the soil here, and if there is a no movement of the wall, okay, then because of that, whatever pressure coming on the wall, that is called earth pressure at rest. But generally, when this type of backfill will be there on the wall, then there will be tendency to move the wall away from the backfill, and sometime other way also possible. So, that means wall movement will take place, and that when the wall movement is take place, that based on that, we have another two types of pressure. One is called active earth pressure, another is called passive earth pressure. Active earth pressure is what? Actually, when the wall moves away from the backfill, and suppose it is moving this direction, then whatever pressure acting on it, that is actually active earth pressure. And suppose the wall moves in this direction, then the pressure on this because of the soil, that is actually passive earth pressure. Now, you have to know, or you have to get idea this out of three: earth pressure at rest, active and passive, which is the maximum and which is the minimum. You can see that at rest condition, whatever pressure will be there, if the wall moves away from the back, it is loosened. That means, because of that, pressure will be reduced, definitely will be reduced. So, active earth pressure will have minimum pressure, and it is in fact is less than the pressure of at rest. And similarly, when wall moves towards the backfill, then pressure will be increased, and in fact, it is more than the earth pressure at rest. So, that means, maximum will be passive, intermediate will be at rest, and active earth pressure will be minimum. So, these three pressure type of earth pressure is there. So, earth pressure at rest, that is called K naught condition. And now, we can see to get earth pressure, as I have told you that wall moves. So, this is wall, suppose wall moves in this direction. Okay. How much movement is generally is expected before failure? If movement is more than that, then you consider it is fail. So, you can see this diagram shows, you can see, as already I have told, that K naught condition, this is the pressure, and when it is Ka, the movement will be this much, 0.005 h, movement away from the backfill, and then movement towards backfill, and that movement is 0.05. If the height of the wall is h, then 0.05 h maximum wall movement can be there for passive case, whereas 0.005 h movement is possible before failing in active case, and this movement is maximum is given, but again based on soil type, again there is a dense sand, this is actually 0.001 h to reach active pressure. This is for active, not passive. So, here is given 0.005. So, here it is dense sand, it is given 0.001. When it is loose sand, it is 0.004. When it is steep clay, 0.01, and when it is soft clay, it is 0.02, and where h equal to height of the wall. So, that means, if wall movement is more than that, that to be treated as a failure actually. And so, this is actually, that means, this is the diagram shows, qualitatively I have mentioned that earth pressure at rest will be intermediate, and active will be small, and passive will be big. You can see the maximum wall movement, minimum minor movement, there is no movement. So, this is active, this is passive, and this is K naught, there is no movement. Now, one more qualitative observation. You can see active case and passive. K naught case actually generally we do not discuss so elaborately, because that is not a problem. Most of the time we inquired are either active or passive. So, you need to know more about active case and passive case. So, active case and passive case, what is the highlight or what is the important characteristics? So, you can see when active case wall will be move out, when active case wall moves out, whereas in passive case wall moves in. As I have told you, this is the wall and this is the backfill. So, the wall this then active and wall is this towards backfill, that is passive. And shear stress on failure plane reduces, that means active case, since you can see the wall when it is a no movement, whatever pressure will be there, if wall moves, that means it is reducing, pressure will be reducing over time. So, shear stress on failure plane will be reduces in active case, whereas shear stress on failure plane will increase, okay, because wall is pushing this side. So, additional pressure will come. Lateral pressure reduces, that means it was initially was sigma naught and then it is suppose sigma active. So, sigma naught will be greater than sigma active, and lateral pressure increases, initially was sigma naught and then you become sigma p. So, that is greater than sigma naught. The minimum lateral stress achieves when soil fails, that means this sigma naught, from sigma naught the pressure is reducing. What will be the limit? Limit is finally at failure will reach, just before failure reach to the minimum value, that is called when the minimum lateral stress achieved when soil fails and full strength is mobilized. And similarly, maximum lateral stress achieves when soil fails and full strength is mobilized. So, sigma naught to finally achieve sigma A, and sigma naught to sigma P achieves here. So, just before failure. And you can see here that for at rest condition, you can see the lateral pressure at rest. Some we have to, as I have told, that it may not be important aspect for most of the cases. Either you have to do active or passive. Sometimes we need to do at rest condition also. So, at rest condition not much things are available or not much to do. So, cannot actually at this point, suppose this is a soil, this is a wall and this is backfill soil and this is a foundation soil. At any point I can imagine a stress condition. So, here actually sigma v will be there, what we can calculate based on the soil on it, above it, and I can find out lateral stress. The lateral stress will be small, less compared to that sigma v, and which will be equal to K naught times sigma v. So, K naught is the lateral earth pressure coefficient at rest condition. So, this sigma h and this sigma h is same, actually you can write small actually h, and so and this is also small k you can write. So, K naught actually is nothing but sigma h dash by sigma v dash. So, at this point, at any point, suppose I consider one point here, I find out what is the vertical stress and what is the horizontal stress. Ratio for sigma h by sigma v is the K naught, and for K naught calculation it can be derived of course, but this is a well known formula. Generally we use K naught equal to 1 minus sin phi dash. If the soil phi is soil has internal friction angle is equal to phi, then 1 minus sin phi will be the K naught. So, if you know this, then multiplying by this with the pressure, one can get the earth pressure at rest condition on the wall. And you can see, if I want to see the Mohr circle corresponding to the at rest condition, you can see that if the soil has a friction angle equal to phi, then this will be the your failure envelope, okay, and your your at rest condition sigma v, suppose this one, and sigma h, suppose this one, or sigma h or sigma h or x, h can be there, it is z or v, either of way. So, if I draw a Mohr circle here, and this Mohr circle will be, you can see as it is shown here, it will be much below the failure envelope, because it has not reached to the failure. When it reaches to the failure, it will become tangential, because Mohr circle we do and draw the tangent, from there only find out. But here, if you have if you have the at rest condition, if you calculate, so if I draw a line with phi degrees, phi angle, which is the internal angle of the friction of the soil, that gives you the failure envelope. And now, based on at any depth, you find out sigma v and sigma h, and if I plot this one on this Mohr circle, and this Mohr circle will be always much below the failure envelope, it will never be tangential. Okay. So, at rest condition, whereas you can see that is at rest condition, we have shown wall is intact, but when there is a lateral earthquake, active or passive, you can see this is of course too exaggerated, it is shown. You can see the wall is here, and this type of wedge will form and will try to go down. So, because of this wall also move in this direction, wall will move this direction, and you can see. So, that means when wall moves out, that means at this zone we are getting active pressure. Similarly, you can see here, when there is a foot on the toe side, this much soil was there. When wall is moving this side, that means this wall is moving this side, that means towards the soil. So, that means at this point we have passive pressure. So, both if there is a toe side, there is soil, then because of the active condition at the backfill side, then at the toe side there will be passive also. So, most of the time the passive pressure helps the stabilizing the wall. So, most of the time whatever small height is there, we generally ignore, and if we ignore that, we get the shaper value. And this is, so that means this wedge will be trying to slide down, and because of that wall moves this direction, and also because of this there can be tendency of movement of this wall like this laterally also. If this moves laterally, then at the bottom also there will be some friction develop. So, that is also there. So, all those things are there. While doing the stability analysis, we can consider all those, and based on calculation. So, first of all you have to calculate what is active pressure, what is passive pressure, what is sliding friction, then only you have to do the stability analysis. So, before going to that, let me take one more. So, this is actually active earth pressure. Now, what was that is shown as general, this is our active, and so when this active earth pressure happened, this wedge actually from the horizontal, this line, this failure plane makes an angle 45 degrees plus phi by 2, where phi is the angle of internal friction of the soil, and so this will be there. And so, based on that, if I can now draw a Mohr circle, you can see, if you draw Mohr circle for active case, you can see this, you can see the so this was at rest condition. Okay, sorry. This was at rest condition circle. This is the Mohr circle at rest condition, and this will not change actually. And this is the wall, because the movement of the wall, as I have told you, that horizontal stress will be decreasing. So, horizontal stress decreasing like that, and finally, it reaches to here just before failure. So, this is the value, lowest value. So, in the active case, this is the Mohr circle, and you see this Mohr circle now become tangential to the envelope. So, what will be the failure plane? This is the pool minimum value of stress at the failure. So, from here to tangent to this circle, if you join, that will be the failure plane, and you can find out this angle is 45 degree plus phi by 2. So, this is, that means your original vertical stress, this is actually this is major principal stress and this one is minor principal stress. Okay. So, with this I will just stop here for this slide. This module I may take passive also and other aspect in the subsequent presentation. Thank you.